Once again to the almost like a final tutorial of Kotlin, all the essentials that you need to know. And yeah, today I will be teaching you, and my topic of discussion will be uh, annotations and a lot of interesting things like inline functions and some tips and tricks like some higher order functions like with, run, apply, let, okay, which helps you to actually do some advanced programming. And I will try to explain you these concepts, okay. And hopefully this will be my like last video of my like whole lecture about Kotlin essentials, all essentials that you need to know. So I guess if you have been following me from the beginning, then like I guess till now you have learned a lot of interesting things about the Kotlin essentials, that things that you need to know before doing programming, right? Like writing programs in Kotlin languages. So okay, without making any delay, like let's start the topic of discussion. So what is annotation? Actually, annotations are read by compiler and used to generate code or even logic. It is a way of attaching metadata to code, and most importantly, annotations are like a tag. Okay, so okay, what is annotation? Let's try to create a simple annotation. Okay, programmatically, annotations, like let's create an annotation function. And what is annotation? Okay, it's a kind of a tag, okay, which is actually declared here before. It can be also, annotation can be ahead of a class. Like also, let's first create annotation. Like you always create annotation with this tag. And okay, for example, this is a simple example of annotation, that is a target API, and my value will be like my API level will be starting from value 21. Okay, so if you see, this is a simple example of annotation. Okay, so that means it's like a metadata which is giving a information to the compiler that okay, you know, this function, the target API for this function execution is 21. Okay, right? So it's a kind of a tag, which is usually you use this tag to like if you go and check out, if you see, these are also already annotations here, right? Retention annotation, target annotations, you know, these are the annotations. If you see here, which is actually giving further information, which is a tag to give information to the compiler. All right, so this is the simple understanding of annotation. And if you go out like for instrumentation test, also you see you can use the annotation to also in before the class. And you know, this is giving information to compiler that it's running with Android JUnit 4 class. Okay, and for example, you are annotating a class which is annotating as a test. That means this is a test like function, right? And also, like you see here, this is also a test function. It's saying that, so you know, like this is a simple idea and concept of annotations, right? And you will encounter this kind of annotations multiple times in the programming, so don't get confused of what is this. Actually, it's like a metadata. Okay, it's like a information you are giving to the compiler, which is read by the compiler to generate the code or even logic based on the what kind of annotations are you making. It's like a tag. Okay, so that's it. Okay, from for annotations. Now let's try to understand some higher order functions, like which is provided by Kotlin to make programming much easier. Okay, so what are these higher order functions? So let's go back. Let me create a higher order function. So what is a higher order function? Actually, higher order functions are as I also have explained you before in my lecture. If you have not seen my previous lectures about Lambda and higher order functions, you go and please check it out. So, and higher order functions are actually a function which is taking a parameter as a function. So let me take a okay, let me take as a name and is a string. Okay, and let me make this one. Okay, let me pass also a function which is taking another function as a parameter. Okay, so let's take a function, and for me, like, my another function will be a lambda, that is, as you know, lambda is a function without a name, right, which is taking input as an integer and giving output as a type integer. So this is a simple example of higher order function, right? And okay, and some of the higher order function which is already provided by Kotlin that I wanted to explain you, like this with, run, apply, let. Okay, so let's try to create a simple example to understand things much better. Okay, like, let's create a list, mutable list, list of a string. Let's me create equipments like food, like apples, fruits, I mean apples, carrots, apple, carrots, orange, right? So you have a mutable list. Now, okay, let's talk about well, let's food. Okay, and my food is of a string and it's a rice. Okay, so there is a first thing that you have to understand is with it's performing, this is a higher order function which is performing an action to a given property. So you know, like, you can use with food, you can perform some certain action, right? What you can do, for example, I want to make this rice all capital letter, like, for example, let me change this, it's all small letter, so I want to capitalize it. So you can capitalize it. You know, this is a kind of a simple implementation of higher order function. What is it doing is taking the input, and we are it's a higher order function which is taking food as a parameter, and it's doing this thing, like capitalizing it, so it's passing the parameter, and this is a string, is the value of this one. Okay, so and also, like, the second one is run. It returns the result of a function. So val result of a function, so you run. Okay, mutable list, let's run this. So what it is going to do, it's going to return the result of function. So that means it's going to return the result of what is going to happen here. So what I'm going to do is I'm gonna take the mutable list which I'm passing here. I'm passing the mutable list in this higher order function. Then what I'm gonna do, I'm gonna get just the first element. Okay, so what is gonna return is just the result. Actually, the result of this function will be the first element means carrots. Okay, and similarly, there is also another higher order function which is returning a return object, which is, as I tell you, if you apply, it returns the object of which is applied to. So for example, if I pass the same mutable list, then I apply, and in this case, if I apply and I'm gonna apply, what I'm gonna apply is I'm gonna add another fruit, that is what is another fruit? Apple, orange, like mango. Okay, so you know, in this case the result will be, actually it is returning mutable list with also the elements, new elements, that is like, now right now we have apple, carrots and orange, so it is also going to add mango, and it's gonna return this value, mutable list. Okay, it's gonna return mutable list. So okay, so this is the difference, right? The first thing, if you use run, then you are going to return a result, whereas if you return use apply as a higher order function, then it's going to return the object. Okay, after you apply and do something, it's going to return something. Okay, and yeah, this is the simple difference of this kind of higher order functions. I would strongly suggest to use such kind of higher order functions to make programming much easier. It's a advanced way of programming and making things easier. And then finally we have the let is particularly useful for chaining okay, anyhow, let also has a lot of important utilities. Like I will show you. Let's say like I have a list which is of type mutable list of int, and which is nullable. That means I can pass here null, right? And what I can do is list, I can check if it is null, then I can say let. That means if it is null, I first check the null. If it is null, then let this. Otherwise, if it is not null, like if it is null, don't do this. Okay, I mean, if it is not null, then do this. Okay, then it will let do perform some action. So what I'm gonna do is actually it's returning. If you see here, it's returning it. That means actually you can also pass here a value that is a list. Okay, let me create a x as a my actually it's returning mutable list. So mutable. Okay, you can pass this as a mutable list, and you can do mutable list dot add. Okay, so I can add a new item. That is this time I'm gonna add I create a list of what I can create a list of I don't know what I can, but anyhow I can create a list of this AA. But it's an integer, right? So I cannot add a, it's a string, so I can add a. Okay, list of numbers. I can add okay, then I think I can also chain another one. I can create a okay, for here it's returning a boolean. Okay, that means it's oh, okay, it's returning the result here. As you can see, the mutable list has added the item, so it is true or false. And this is the okay, let me also use the let's create another example. For example, you can use like value is pump. Okay, and what I can do is value let t plus kin. Okay, and you can still do let okay, you can still have to do it. You see, I'm making a chain, like the value is actually pump, right? Then I'm adding k, then I'm adding ing, right? So this is a way of, you can also actually chaining manipulations together. Okay, and actually, you know, the result is being returned in each manipulation of let, the result is being returned, and the same result is being returned. Okay, here, and like same result is being returned. So you can also add multiple chain. So actually we have the result here. Okay, and the result, okay, with this one, right? So this is one of another higher order function that is important, like that is important and can be useful for you guys to make your programming much easier. And also the most important thing is like to check the null check also, right? You can have a null check here, like if it is not null, then perform those actions. And yeah, this was the simple explanation of some higher order principles of programming in Kotlin. And yeah, finally I have an inline function. Okay, and actually inline function is what is inline function? Okay, also like in order to reduce the memory overhead for such higher order functions or lambda, like I gave you an example of this one, higher order functions, right? So in order to reduce the what it says, the memory overhead of such higher order functions or lambda, we need to use the inline keyword, which ultimately requires the compiler to allocate the memory and simply copy the inline code of the function at the calling place. That means these higher order functions, to reduce the overhead, because they have a whole overhead, because you know these higher order functions sometimes, you know, like it's passing, you are passing the input as a like a function as an input here, right? Another function as an input. So they can have an overhead because of functions, you don't remember this all functions maybe is also another higher order functions. So you know, like in order to reduce the overhead, you can just pass a inline code here, like inline keyword here, and the compiler will easily what it does is it will simply copy the inline code of the functions at the calling place, so it will reduce the overhead. So this is the simple concept that you have to understand. And yeah, like without inline, object is created on every call. So every call, you know, like for example, just imagine if without the inline, like this higher order functions has also another higher order functions here. So every time the, you know, like and also maybe this higher order function, like these functions, input functions, maybe also have another higher order functions as an input. Okay, so you know, like just imagine like when you have a complex a huge programming code, like your new project is very huge, then it can create overhead. That means reduce your execution time, you know, the compiler's execution time. So um, uh, so just to reduce the overhead, we have to like the best practice is to use the inline function, right? Inline keyword and create a inline functions. That's why compiler will easily like understand that it's an inline function, so it doesn't create a new object, okay, each time on every call. So that was the concept, guys. And guys, thank you for reading and following me through all these lectures, because I made a series of lectures for Kotlin, all the essentials things that you need to know. I hope you guys are right now in the very good stage of starting to program in Kotlin. And if you have yet not subscribed me, just please subscribe me and support me. And thank you. If you have any questions, just comment me below, and like you can just ask me. And thank you for following me. Okay, and see you on my next videos. Thank you.